I had just said sorry, not sorry, because we're going to continue at 8.5.
Yep. There's a lot of these guys, so it does take a while.
Three more organic acids, amines, and amides.
Okay, good. And these guys are a little bit complicated. These are the COOs.
Yep.
So it's a C double bonded O with an OH.
Mm-hmm.
We call this a carboxyl group.
Yeah, not a carbonyl, but a carboxyl.
Right. So let's practice drawing these things in.
Wait a minute. They're acids, Milk. What do they produce?
H plus or H3O plus, which is hydronium, in solutions. They are acids, but these are the organic acids. These were the one weird ones. They were the exception to the rule. Remember, they didn't start with the H like everybody else.
Right. They're typically weak acids. Nucleic acids that get together to make your proteins and stuff.
Yep.
They're organic acids. So every single thing in your body that makes you is based upon proteins and stuff. And organic acids
have a lot to do with that.
Yeah. And they all have this.
I'm just going to break this word down real quick because I see some pieces I know right there. So when I see table R, I see prop-an. So prop tells me 3 carbons. An tells me that they are single bonded. Then I see the deviation from propane is this oic acid piece. So right off the bat, where do I see oic acid on there as far as a naming structure from the examples? There's propanoic acid right there. And I see my functional group. Well, what are you doing?
Oh, man, I keep forgetting. I like drawing these things. I forget that you got the magic.
Yeah, so prop is 3. Oic acid says put a...
That's butanoic acid, bro.
Yeah, bro. All right, you draw it then.
Bro, yes. I want to draw propanoic acid, and I'm going to do it right.
Dope. 3 carbons. We're going to have a double bonded O and an OH on the other end. That is propanoic acid. And how I got this wrong last try. Moving on to the next piece, I see 1 carbon. 1 carbon is meth.
Yep.
This is methanoic acid. And again, just like the aldehydes, I don't have to put a 1 in front because it will always be the terminal carbon, we call that. The end carbon is the terminal carbon. A little side note on there. So that's that. Yeah. Questions about oic acids?
No.
Other than they have a really funny name.
They're easy to recognize. You've got to know them by recognizing them by sight.
Yeah.
I mean, reference table is important, but you could get cross-eyed with the double bond. Oh, you might think it's an aldehyde or a ketone.
Just saying that. Can we just circle the functional group real quick?
Yeah.
Because that's what we're actually. That's the piece, and on your drawing too, sir.
Yes.
Because that shows us what the functional group is. Finding the functional group helps.
An organic acid is a combination of a carbonyl group and an alcohol.
True. All right. Now these are not ethers. This is
Esters.
esters. We're going to see if I did this one right.
Yeah.
Okay.
Let's see.
Okay. Let's see.
Ethyl butanoate.
Oh, can you say that one more time slow? Butanoate.
Ethyl butanoate.
Oh my gosh.
So esters are like ethers in that there's an oxygen bridge in the middle, but it's right next to a carbonyl group. So you have to name 2 branches.
Correct.
Ethyl branch is, well,
let's find this 08. Let's define me the 08 in the actual naming. Who ends in 08? So now as soon as I do that, I can identify it's an ester and what the functional group is. Okay, so there's my functional group, and I have an ethyl and a butanoate. So here's the trick. Ready?
Yep.
You see that carbon in there with that side chain? Well, the bute in the butanoate. I was touching the screen like you could see me touch it.
Yeah.
That's got to be the 4 carbons. So 3 more carbons got to go on there, and that's where I get my bute.
Mm-hmm.
Okay, and then ethyl tells me how many? 2. So there should be 2 carbons on the other side of the O.
There's your molecule.
That's the actual molecule and what it looks like.
Let's see. Let me try naming this.
Okay, well, circle the functional group. There we go. And notice there is a 1 carbon side chain, which is methyl. And then there's 3 carbons in there, so that is a prop and O8. The AN tells me it's all single bonded. Okay.
Yep.
Methyl or propylmethanoate. Let's see if I did this one right. So right off the bat, 08 tells me there's
it's an ester.
Ester, right?
Mm-hmm.
I was going to say carbonyl group, but it's not really just, right? So I have propylmethanoate. The meth has got to be in the 08, 1 carbon.
Yep.
Propyl on the other side.
Yep.
3 carbons.
You did it right.
Woo!
You done did good, kid.
Oh boy, I was nervous there for a second.
Mm-hmm.
Moving on, we already did this.
Did it.
Did that one already. Let's do amine.
Amine, when a nitrogen shows up in your chain somewhere, either it's
Okay.
in the middle or on the end.
Okay, good.
So, what do you got for us? Propane
Amine. Okay, so prop is 3 carbons.
Yep.
And then the amine goes on the first carbon. Boom.
There it
So you gotta
is.
just take a whole NH2 and put it on there.
Pent anamine. Can I do this one?
Okay.
Pent, 5 carbons, single bonded with a nitrogen in there somewhere. Where? Second carbon. 1, 2, 3, 4, 5. Second carbon, nitrogen. Fill it up with hydrogen. Done.
You did it. I'm good at this, Monaco.
I do like to draw.
I do. I like to too. And this is actually one of my favorite units because I really love how it's
He said 2-2.
systematically.
He said 2-2.
I'm
Just
not
want to
wearing.
point out, he said 2-2.
I'm wearing jeans.
Last one, let's figure out a name here.
Ooh.
I know this one. This was tough because the nitrogen's in the middle of the chain. So when everything your functional group
Being this part
Is in the middle.
of the chain.
you got to name the branches,
Branches.
with the ills. So
Right.
I'm gonna guess,
Ooh. I see 1, which is methyl.
and then I see a 2 carbon, which is ethyl.
Ethyl.
So
Ethyl,
ethyl methylamine or methyl ethylamine.
I like that.
Either way,
Either way, I think actually by convention we do ethyl methyl.
okay.
Do the lowest letter in the alphabet first. But
Okay.
it doesn't really matter. I think it's I give you credit.
6-1, half dozen in.
Yep. So ethyl methylamine.
YL.
Beautiful. Ethyl methylamine.
Last
of course-
and least common.
Yep. Let me blow through these animations quick because
Yeah,
you know I had it
you know,
animated.
I just like drawing.
I know.
Amides are like amines, except they're right next to a carbonyl group, a C double bond.
A little bit more complicated.
Yeah.
So in table R, we see something. Look for that amide in the example name. There it is, amide, and it just so happens to be the class of compound is amide, and that's nice that it ends in amide. Prop tells me it's 3 carbons. He doesn't want to see me do it. He wants to go ahead and do it himself, and I don't blame
I
him.
want to see if we get the same.
Okay, let's see if we get the same this time. Okay, that's what Monaco's got, and he's right. 3 carbons is prop. Can you just pull that whole thing up?
I wish. No, I can't.
Oh, it won't let you. Okay, let's just see what my animation does. 3 carbons, right? Boom.
Yeah.
Yeah,
It's
I
the
put,
same.
yeah, I put it on the right place. Yeah. I figured out what I do with the last one wrong. Okay.
Butanamide. Let's see if I get this
Butanamide,
right.
right.
Bute, 4 carbons. Carbonyl.
Carbonyl with a right? With
Mhm.
the nitrogen on the other end. That is butanamide, which looks like a lot like a propanamide, except for it's got 4 carbons instead of 3. We good.
Yeah.
We good. And guess what? Once I get through the animations that I did, prove that I did it right too.
Yeah. Wow. I almost did that perfect over yours.
Yeah, that was good. That's all, folks. Hey, now you guys are actually ready for the lab
Right.
to go through all of these things, drawing them up and making them.
And for serious, I don't expect you to be able to do all this just from watching this lecture because I took an entire course in college just on
That's
organic chemistry.
You guys, 2 of the courses actually, 1 and 2.
Semester 1, semester 2, a
Yeah.
whole year on just this unit's topics.
Yes.
Crazy.
See ya.
See it. I could click buttons somewhere in here. There it is.